Hi there, I'm Ms. Kacharsky, and today you're going to be learning about equivalent fractions with me. So by the end of this, you should be able to recognize simple equivalent fractions, and you should be able to understand that two fractions are equal if they are the same size. So in the previous unit, we learned the basics of fractions. We learned that a fraction is an equal part of a whole. We learned that the numerator is the top number. It's the number of parts that are usually shaded in. The denominator is the bottom number, and it's usually the total number of parts that your model is broke up into. Now we're going to learn about an important category of fractions called equivalent fractions. Equivalent fractions are equal fractions. They are fractions that are equal to one another. To be equal, the fractions must be the same size. In this lesson, we will learn about equivalent fractions and how they are the same size. Let's get to it. Here's a rectangle divided into two equal parts with one part shaded. Think about what would this fraction be? If you said 1/2, you're correct. So we're going to be looking at fractions that are equal to 1/2 in this beginning part. Here's another rectangle broken into 4 equal parts. So what would my denominator be? And then it's shaded, 2 parts of those are shaded. So what is my numerator? If you said 2/4, that is correct. So what do we notice about the two fraction models of 1/2 and 2/4? Looking at them, they are the same. That means that they are equivalent fractions. The same part is shaded in. Since 1/2 and 2/4 are the same size, they're equivalent. Keep 1/2 and 2/4 in mind, and let's look at this rectangle. It has 6 parts, and 3 of those parts are shaded in. What would my fraction be? If you said 3/6, you're correct. How does this fraction model represent 3/6 relate to 1/2 and 2/4? Let's look at all 3 of them together. So here's my model for 1/2. Here's my model for 2/4. And here is my model for 3/6. What do you notice? You're saying, hey, Miss K, all of these parts that are shaded in are all the same size. They're all taking up the same part of the rectangle, which is half of the rectangle. You are correct. They are all the same size, which means that those are equivalent fractions. One important thing, though, again to remember, is that each of these rectangles are broke up into equal parts. If you were to make your rectangle and you didn't have equal parts, then those fractions would not be correct. So you definitely want to make sure that it is broken to equal parts. Now we're going to take a look at a fraction model for 4/8. Again, my rectangle is broken to 8 equal parts, and 4 of them are shaded in, creating 4/8. Compare this fraction model to those of 1/2, 2/4, and 3/6. Let's see what you notice. If you're noticing they all take up half the rectangle, you're right. So what do we call that? If you said equivalent, you're correct. Those are all equivalent fractions. They all have half of that rectangle filled in. So in order for a fraction model to be accurate, you need to have rectangles that are the same size. So my model needs to be the same size. It doesn't always have to be rectangles. It could be a square. It could be a circle. And you need to divide those rectangles into equal parts. You can then use these models to see which fractions are equivalent fractions or equal to one another. Since we have seen the fractions equivalent to 1/2, let's look at some different fractions. Now let's look at a fraction model for 1/4 and 2/8 and see what we notice. So that very first one is broken to 4ths and one part of it is shaded in. Here's my second model, and it is broken to 8 equal parts, and 2 of those parts are shaded in. So what do you notice? The shaded areas are the same size, meaning 1/4 and 2/8 are equivalent. Let's look at 1/3 and 2/6. Again, what do you notice? It is the same size that is shaded in. So you're noticing that this part here is the same part of the rectangle that is equivalent. Also, we have 1/3. We're going to do a little number sentence, is equal to 2/6. You might be noticing something else. What is happening? I'm multiplying each part by 2. So if I took 1 times 2, that would equal 2. If I took 3 times 2, that would be 6. So if you multiply your numerator and your denominator by the same number, you also get equivalent fractions. That's another way to figure out equivalent fractions. So you can draw models like we are today, or you can also multiply them by the same number. Your denominator and your numerator, you can multiply those by the same number and it will get you an equivalent fraction. Now let's look at fraction models for 3/4 and 6/8. So I'm going to erase this part off here for you. So we've got our 3/4, and let's get 6/8 up here. And what do you notice about 3/4 and 6/8? If you're saying, again, the same size of the rectangle is shaded in, you are correct. So 3/4 and 6/8 are equivalent fractions. So what number would you multiply your 3 by and your 4 by to get 6/8? If you say 2, you're correct. If you multiplied 3 times 2, that would get you to 6. And if you divided 4 times 2, that would get you to 8. There we go, sorry, 2. So that would get me my 6/8. Good job. All right, let's go to our last slide here. So let's look at 2/3 and 4/6. And again, what are you noticing? The same amount is shaded in. So that means those fractions, 2/3 and 4/6, are equivalent fractions. So equivalent fractions are fractions, again, that are the same size. Let's review the equivalent fractions we have seen in this lesson. 1/2 is equivalent to 2/4, 3/6, and 4/8. 1/4 is also equivalent to 2/8. 1/3 is equivalent to 2/6. 3/4 is equivalent to 6/8. And 2/3 is equivalent to 4/6. You guys did an awesome job. Now I'm going to show you what it is that I would like for you to do today. So once you are done with this lesson, and the nice thing is you can watch it as many times as you need to, you are going to work on this worksheet here. Here it is. So in this worksheet, it says what fraction of each shape is shaded. Fill in the missing numerator or denominator. So you're going to tell me what is the numerator of the shape that is filled in, or the denominator. So what are those parts that that shape is broke into? And then based on the above, fill in missing numerators or denominators to complete these equivalent fractions. So 1/2 is equivalent to, what do you notice up here? Blank fourths. How many fourths is 1/2 equivalent to? And then what fraction of each shape is shaded in? So you're going to tell me when you're looking at those, what is the fraction of each shape that is shaded in? So all of those together have the same fraction that's shaded in. Then fill in the missing numerator or denominator, then complete the equivalent fraction statement that follows. So 1 out of how many in here? So we've got 1 shaded in, that's my numerator, but how many parts is that broke into? And then we have 2 out of how many is this broke into? So this one has the denominator already for you, but what is the numerator? So you're telling me those denominators and numerators. And then shade fractions of the shapes to show why the equivalent fraction statements below are true. So how is 2/3 equivalent to 4/6? You're going to shade that in to show that that's true. And then 3/4 is equal to 6/8. And then shade that in to show how it's true. Good luck, and thank you for learning with me today.